that. And all this is mostly done by hand. So if you go in here, there's a guy in here, and he moves these freight trains around, these different containers, and he has to actually go outside, look at a piece of paper that's inside this cart, and then write down what number it is, what's loaded onto it, and then pretty much walk from there all the way to his office, and then type it in his computer. So it's all done in an analog manner. It takes forever. So it's really not that thought out, not that intelligent yet. So in that case, you have to implement these ICT technologies in the freight sector as well. So now I switch to the future scenario, and you can see immediately that there's also a lot of dead space that's being used by renewables. So you have a connection to the conventional grid, of course, but you also have then a lot of different power providers, the smart grid. You have buffer batteries for this campus alone. Then you have all these power producers on site, because you can be using this energy for the future shunting locomotives, and that's something that's called autonomous carts. And in some case, or in some ways, already been implemented, but only with big harbors. So that's where you have the cranes take the big containers, the ship containers off the ship, and then put them on AGVs, and they're called automated guided vehicles. So the whole area around the ship is completely unmanned. There's nobody there. It's actually locked off to humans. So these cars drive around on their own, and that's pretty much the same principle that we try to apply to the rail sector. So in this case, you can see a small car that has cargo on it, and it has a little battery symbol. That means because this car also has an autonomous battery. So it's, for one way, it's hooked up to the power grid, so it could get their energy from the smart grid. But then there could be parts like in this photo. Let's go back, because most of these shunting locomotives run on diesel fuel. So if you're in these big freight terminals, there are no overhead power lines. So in that case, instead of building all these expensive power lines, to only have a few of them, and then make them autonomous with a battery inside, so that they can travel over certain areas within this freight terminal as well, without using an overhead power source. And also, it says autonomous, so what that means is it has to be automated, and the car will drive on its own. And you can see this little symbol, little Wi-Fi symbol. What that means is it communicates. So it can communicate between each other. So the distance, where are you, what are you doing, which direction are you going, what are you carrying, or it can also communicate its information to the hub, to the data hub. So people in here, they don't have to walk around and scan everything. They have all the information within their system. They know exactly where the trains are and the carts, what are loaded into them. And the whole goal for this is to make almost like a train Tetris system. So the big trains come in, or the cranes, or might be offloaded, and then the system knows exactly where what has to go. It knows the container number has to be on this train because it has priority. The other one is not so important. That the system knows exactly how the priorities lie, and then can move this around, and then these cars will move these containers accordingly to the train, then complete the train, and then send on its way, just to make these systems a lot more flexible and easy. And then one other part that's really important to talk about is localization, because in Germany we have a problem where it's not legal yet to